Okay, today we will be solving LeetCode problem 3714. It has titled Longest Parent Substring Part 2. The problem says that you are given a string S. Let me, you are given a string S consisting only characters A, B, and C. A substring of S is called balanced if all distinct characters in substring appear the same number of times. Return the length of the longest balanced substring of S. Here one of the example is A, B, B, A, C. So in this case, the longest balanced substring is 4. The longest balanced substring is A, B, B, A because both distinct characters A and B each appear exactly twice. So basically any substring that will have characters, all the distinct character, the count of those substring has to be equal. So if we take example of, let's say, substring BAC, it has distinct characters BA, B, and C, and each has count as 1. So this could be one possible balanced substring, but the length of this substring is 3 only. So this is not the best possible answer. But in case of this substring A, B, B, A, we have only 2 distinct characters, and the count of both of these characters is 2. That's why it is one balanced substring, and the answer, the length of this is 4. That's why the maximum result is 4 over here. Same if we go with the second example, we have A, B, 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 C, C. So in this case, the maximum length possible here is, if we talk about uh, any character with uh, distinct character with one distinct character. So only this substring which has a distinct character is 1 but length is 2. Same here, distinct character is 1 but length is 2 only. But if we talk about the distinct character 2, so that also comes as 2 because A and B is only one substring and B and C is one substring which has 2 distinct characters but the length is 2. So if you talk about the length, distinct character is 3, so A, B, C comes as one substring which has length 3. So that's why the answer here is 3. In this case, A, B, A, if we talk about the distinct character is 1, only 1 appears, substring with length 1. But if we talk about the distinct character 2, then A and B is one of the substring, A and B is one of the substring, and B and A is one substring. But the length of both of them is 2. So maximum result will be 2 itself. So let's see how can we solve this problem. One possible brute force solution would be is try for each of the substring and count the number of distinct characters. If the length of each of the count of each of character is equal, then uh, that will be a balance and we can maximize on top of that. So that is going to be order of n cube, and if we optimize further, then if we try to store the prefix count of each of the characters, then we can definitely get this under order of n square. So if we store count of each characters and we look up at each index, if that count has already been seen in the previous index, that should give us order of n square solution in each of the previous. So for example, let's zoom in on the order of n square solution. So let's suppose we have example A, B, B, A, C. If we take one example, A, B, B, A, C. So in this case, if we keep storing A, B, count of A, B, and C at each index, so we'll have at index 0, count of A, B, and C is 1, 0, and 0. At index 1, we have count as prefix count as 1 and 1 and 0. Then at index 2, we have count as 1, 2, 0. And at index 3, we have count as 1, yeah, it will be 2, and it will be 2 itself. Then this is 0. And at index 4, we have count as 2, 2, and 1. So for each of these index, we try with all the previous indexes and compare if the difference between count of each A, B, and C is equal or not. That will give us order of n square solution, and we can keep maximizing if the count is maximum or not. So that should give us a order of n square solution. This is one approach, but since our constraint is n could be here, the length of the string could be here up to 10 to the power 5, so n square solution will not work here. So the another solution, the more optimized solution that we can come up with is, what if we divide this problem into 3 segments? First segment would be count all the substrings, count the length of all the substring, maximum length of the substring where the distinct character is only 1. That is easier to find out because we can iterate over each of the characters and keep increasing the count until the character is same, and then we reset the count when the character is different, and then again we reset the count when the character is different, and keep maximizing the number of adjacent common characters, same characters. So that will give us maximum length of the substring which has additional character is 1. Second segment would be, so let me write it over here. Segment 1 is count all substrings with distinct character as 1. Segment 2 would be count all substrings with distinct characters 2. Count maximum length of the substring, maximum length of So this is again will be maximum length of all substrings with distinct character 2. Same goes for segment 3. We'll have segment count maximum length of substrings with distinct character as to 3. And at the end, result will be maximum of all segments, right? Segment, either we can choose 1 or segment 2 or segment 3. So this is going to be the result. So the finding the length of the maximum length of the substring which has distinct character is 1. This is very easy. We iterate over the string and count the continuous same characters length of the substring which is the same, which has the same character. So this part is easier. Segment 2 is also a bit easier if we talk about the prefix sums. Okay, we'll get segment 2 and segment 3 as a bit similar to evaluate. What we are going to do in this case is, let's suppose we have a string AAB, and with that let's say ABC. Okay, yeah. So in this case, the length would be maximum length of the substring is 3 itself, or I would rather say it's 4. Yeah, it's 4. So what can we do is, let's take a bit different example. Yeah, so the maximum length of the substring, the result here would be 6 itself, this part, right? Because each of the distinct character contains two count as 2, and the maximum length is 6 itself, right? So if you think carefully, what if we keep storing the count of each characters when we iterate over the substring, the string itself? Let's assume for now that there is a string which has something as prefix when we are iterating over, and anything, let's say A B B C C A B, something like that. Okay, and we don't know, let's suppose right now the count of the characters in this one. Okay, let's suppose that it is going to be the X, and this is a balanced string. Let's suppose for now that each of the count of each character A, B, and C is X itself. Okay, then we know that if we are, while coming up to here, we'll have count of characters A and B, and at the end of this substring, since all of the count of each of the distinct character is X, so at the end of this substring, the count of characters is going to be, let's suppose up at the end of this substring AAB, we have count as, for A it is, let's suppose uh, for now X. Okay, or maybe let's say 2. Okay, and then for B we have count as 1, and for C we have count as 0. So we know at the end of the substring, because since it is a balanced substring, so and count of each character is x, so at the end of the complete string, which is 0 to n, it would give, for A it will be 2 plus x, for B it is going to be 1 plus x, and for C it is going to be 0 plus x. Because we know that count of each character is x, because it is a balanced substring, so what this tells us is difference between difference between A and B at the start of this substring, the balanced substring, is same as difference between any of the two characters at the end of the substrings, right? Before a start and at the end, the difference is going to be same. Pick any of the characters, either A, B, B, C, or A, C. The difference is going to be the same, because we know that the only x, the count of each of the character is same for the substring. So subtracting both of them will subtract this common count, which is x, between them. So difference is going to be the same. So it is safe to say that difference between, let's suppose, uh, difference of A, count of A and count of B is equal to difference of let me write uh, let's suppose this ended at index j. Okay, it has, one second, yeah, so it started at I, and let's suppose I is this index, and then we have uh, it is ending at j. So we can write here that count of prefix count of A till I and prefix count of P till I, and the difference between them is going to be the same of prefix count of A till j, and prefix count of B till j, right? Because 2 minus 1, so let's, here it was 2, so 2 minus 1 is same as 2 plus x, 2 plus x minus 1 plus x, right? So no matter which character you pick, the difference is going to be the same as the previous one. So this is the basic intuition of solving this problem. So here, if we talk about, uh, let's suppose the character for the substring with distinct character is 2, the difference between the two characters, let's suppose either A and B, is going to be the same, right? So let's suppose if we take this example and if we try to find out the maximum number of characters with distinct maximum number of length of the maximum substring with distinct character s2. So the count of character A, uh, so if we keep incrementing the count of A and decrementing when the count is B, it is at any index if we find that the sum is 0 and or maybe any sum that has already been previously seen, it means that the count between them is same, right? So what we can do is basically so let's take this example for now, uh, A, B, B, A, C. So here if you start from A, you'll increment when since it is A, you'll increment it by 1, and when it is next is B, so you'll decrement it by 1. Next is B, you'll decrement it by 1, and then you increment it by 1. So at this point, when it is A, B, B, A, this is going to be 0. It is a balanced substring, right? Because A will also become 0, B will also become 0. And you will be able to see that at the start also we'll had the sum as 0. So the length becomes 4. So same way we can try for other combination as well when the character is B and C and when the character is A and C. Okay. So that will give us the length of the longest substring which has distinct character as 2. But if we talk about the length as 3, so this solution that we just talked about, this will work. This is going to be work properly because at the end of any substring, we can calculate the difference between each of the count of each of the count count of each of the characters. And since that if that particular set is already seen, so we can mark that as length of the longest substring, right? This same trick can also be extended for characters with four, four of the distinct characters. So, okay. So for the segment 3, we keep at each, we iterate over each index and calculate difference between each pair. If that is already seen, it means we have a balanced substring. This same logic can also be extended for the distinct characters when it is 4. So here, when the difference between, let's say AB and BC and AC each same, it means that this particular tuple, if we have already encountered before while iterating over, it means we have a balanced substring, right? And we can maintain sort of like a hash map with uh, last index where this was same. Okay, and we can calculate the difference, get the length between. If it is same, then we can get the difference between G minus current, let's say current index minus from the map we can get the whatever is stored in this tuple AP, difference AB, BC, and AC. So this will give us length of the balance substring, and we can keep maximizing of for it. Okay. For if we try to extend this problem for the distinct 4 characters A, B, C, D, then since there are 4 characters A, B, C, and D, we need to maintain this difference for all these pairs. So it is going to be for A, the pairs are going to be A, B, then A, C, then going to be A, D, then same for B, it is going to be B, C, and B, D, and for C, it is going to be C, D. So these 6 pairs, we have to maintain the difference between each of the 6 pairs, and if we can keep a check if these 6 differences has already been encountered previously while iterating, it means that there is a balanced substring, a substring exists where the distinct characters are 4 and each of the character has a equal count. So that is the intuition for this. Okay. So let's go ahead and code the solution now. First of all, let me write the pseudocode. So we need to find for the case 1, let's suppose when character is 1, distinct character is 1, we need to find the maximum length of the substring. Okay. And we iterate over the whole string and we maintain a counter and the current counter as 0, then and I will be iterate till the end of the string. And what we are going to do in this is, if the since we know that it is always going to be one character at least, so let's start from one itself. If the previous one, so s of I minus 1 is equals to s of I, it means that we can increase the current counter itself. Otherwise, we can maximize the distinct character 1, and it will be the current character itself, the previous one, and we'll reset the counter as well, equals to 1. And for the second case, when distinct character is 2, so we keep iterating over the string until the it is same as the previous character, or maybe same, not more than two distinct characters. So that is pretty easy because we keep iterating. Let's suppose in this case over here it is A and A. So if we encounter A, we see that there is not more than two distinct characters. So we add it, then we encounter B, still not more than two. So we add, again we add, again we add. So we keep adding until you encounter C. So upon adding C, it will become distinct character as 3. So we reset it, we maximize the length of the string that we have got, and we reset the counter. So now we should start from our previous ones, right? So here it will be, since we are going with this below approach for finding count of A and B, so we go ahead and for increase the counter of A, when A encounters, we increment the counter by 1, and when B encounters, we decrease the counter by 1, and we keep doing that until we don't encounter any other characters, and then we reset it again, and then for we check for B and C if there is any. So we again iterate over, and then we check if B has character but there isn't any for C, so we reset it again. So we again encounter A, we reset it again, then we encounter B. So since we are checking for B and C, so we'll increment the counter for B, again we'll increment for B, and then we decrement for C, and we decrement it for C. So again we find one substring as B and C. Yeah. So this will be 4 characters, and in this case it is going to be 6 characters. 2 to 4, and yeah, 6 characters. So that's the trick for the second segment. Let's see. So for second segment, we try for AB, then we try for BC, then we try for AC, right? Then for segment 3, we have we also maintain the sort of like a map which store a string as key and the index for that integer index. So sort of like a tuple index map, and we iterate over so if the character so ch equals to s of I, so if character equals a, then we need to or maybe let's do one thing. Instead of this, we keep a count for A, B, and C. Initially, it will be 0 for all of them. If it is A, then we increment A. If character is B, then we increment B, and otherwise we'll increment C. Now we'll take the difference for AB. AB is going to be count of A minus count of B. Then BC is going to be count of B minus count of C, and AC is going to be count of A minus count of C. And we'll create a sort of a key for lookup where we concatenate AB and BC and AC, and we look up into the map that if map contains this particular key. If it does, it means that we have found a balanced substring and CS3 will be maximized. Map.get key, and we subtract it from our current index. So this is going to be the CS3. Okay. And at the end we return max of CH1, CH2, and CS3. So this is a pseudocode I hope you can code this yourself. That will be better. And I just provided the intuition. Thank you.